Hey everybody, what's up? I'm Neil, and in today's video, I'm going to be teaching you about formal charge. Now, this is a tool that we can use to make sure we have drawn the best possible Lewis structure. Specifically, in today's edition, I'm going to teach you how to take a particular element within a Lewis structure that you've drawn and figure out what its formal charge is. Okay, if that sounds good to you, please like the video and subscribe to the channel, and let's get started. So to begin, we're going to start with methane, or carbon tetrahydride, and you can see I've drawn the Lewis structure for it on the board behind me. Now, we're going to calculate the formal charge for both the hydrogen atoms and the carbon atom. Let's start with hydrogen first. Now, formal charge, which I've abbreviated Fc, is equal to the number of valence electrons that an element normally has. When I say normally, I mean before it's participating in the molecule. So to get this number, you just look up the element on the periodic table or think about its electron configuration. So in the case of hydrogen, it normally has one valence electron. Now, we're going to be subtracting some numbers from that number 1. Let's go over to the green part of our equation. The things written in green have to do with hydrogen and its role in the molecule. So, first off, when it says lone electrons, we're looking at the hydrogen atom and we're asking ourselves, do we see any dots around it? Do we see any electrons that it's not sharing? In the case of all of our hydrogens, I think you would agree that there are no lone pairs, there are no dots. So for this example, that's going to be a 0. Okay, next, it says half of the shared electrons. Now, of course, if an element, an atom, is in a molecule, it's sharing electrons. But the question is, how many? Here we see that this hydrogen only has one single bond. And a single bond represents 2 shared electrons. So we need to take half of that number. In other words, half of 2, which is 1. Okay. Now we're ready to calculate the formal charge. The formal charge of this hydrogen is 1 minus 0 plus 1. I think you would agree that that equals 0. So the formal charge of this hydrogen atom in this particular molecule is 0. And I'm just going to write that underneath the element. Question: do I really need to calculate the formal charge for all 4 of the hydrogen atoms? The answer is no. I went ahead and labeled all of them with the 0 that we calculated for the first hydrogen. I was able to do that because none of these numbers would change, regardless of which hydrogen we're looking at. When you're doing a Lewis structure with multiple atoms of the same element, you can save yourself some time. If those multiple atoms of the same element have the same number of lone electrons, in this case it was 0, and the same number of shared electrons, in this case it was 2, we took half of that number, then all of the atoms of that element should have the same formal charge. So don't calculate them multiple times. All right, so what about that carbon? Well, we're going to take the same approach. To find its formal charge, we're going to start by asking ourselves, how many valence electrons does a carbon have naturally? And the answer is 4. Next, we're going to look at the carbon and what it's doing in the Lewis structure. Do we see any lone electrons around the carbon atom? In other words, any dots, lone pairs? The answer is no, there are 0. Now, finally, we ask ourselves, how many shared electrons does this carbon atom have? The answer is 8. 2 for each of the 4 single bonds. Now remember, we have to take half of that number. So half of 8 is 4. Okay, now we do the math. 4 minus 0 plus 4, which is 4, gives us another formal charge of 0. All right, I hope that makes sense to you. Let's look at an example that you can try. So now I want you to put your skills to the test. Behind me is a molecule of ozone, O3. I want you to try to figure out the formal charge for all 3 oxygen atoms in this molecule. Will they be the same? Will each one have its own unique formal charge? Pause the video, try to figure it out for yourself, and then come back for the solution. All right, here they are. How did you do? All 3 of these oxygen atoms should have a unique formal charge. Let's take a look at why. Starting with the oxygen to the right, we know that it has 2 lone pairs. In other words, 4 electrons that it's not sharing. Now it also has a double bond, which means it's sharing 4 electrons in that double bond. But remember, we only take half of those. So we've got 1, 2, 3, 4 lone electrons, 4 shared electrons, half of which is 2. So the total here would be 6. Now oxygen atoms always have 6 valence electrons. So for this first oxygen, we're taking 6, subtracting 6, and that gives us a formal charge of 0. Let's move to the central atom. In this case, we see that there are 1, 2, 3 bonds. So that's 6 shared electrons. So we're going to take half of that, right? That's 3. It also has a lone pair, so those are 2 electrons that it's not sharing. So we've got 2 electrons in that lone pair. We take half of the bonding electrons, so that's 3. 2 plus 3 is 5. Now again, oxygen starts off with 6 valence electrons, so the calculation is 6 minus 5, which gives us a plus 1. Okay, the last oxygen has 3 lone pairs, a total of 6 electrons that it's not sharing, plus it has a single bond. So those are 2 electrons that are shared, and we take half of those. So we've got 6 electrons plus half of these electrons, which gives us a total of 7. So it starts off with 6 valence electrons. In the molecule, it has 7. 6 minus 7 is -1. And that's how you get these formal charges for ozone. All right, so that's going to do it for this lesson. I hope this was a quick and easy tutorial that helped you figure out how to figure out formal charges. If you still have questions on what to do with these numbers, what's their significance, how do they help you pick the best Lewis structure, I'll be making another video on that topic, so check it out. Once again, if you could like the video and subscribe to the channel, that would mean so much. And thank you as always for joining me.